Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Let us continue with review exercises about chapter 7, techniques of integration. Uh, Evaluate the integral. I have e to the power x, e to the power negative 2x. Well, I notice that I have e to the power negative 2x here, and e to the power negative 2x, in fact, is e to the power negative x to the power 2. And I notice that I have e to the power x here, so I can take it. If I take it up, it would be e to the power negative x dx. So this suggests that I take u equals e to the power negative x. Then du would be negative e to the power negative x dx. And then this integral will be translated to change it to du, but I need a negative sign outside, over square root of 1 minus u square. And this is exactly sine inverse. So sine inverse u, and u is e to the power negative x. So that's the answer. Now, the improper integrals show that it's divergent or evaluate the integral. This is integral from 1 to infinity. The definition is we take t to infinity and change infinity to t. And now we evaluate this integral. Now, how to evaluate this integral? I have 2x plus 1 to the power 3. So if I take u equals 2x plus 1, then du would be 2x dx. Then I can write it half integral 1 to t, and no, not 2x, just 2, okay, because the derivative of 2x is 2. So 2 dx, I can write it du, and 2x plus 1 is u, so u cube. If you want, you can take the half outside even the limits. And now this is u to the power negative 3. The integral is u to the power negative 2 over negative 2. But I need either to go back to x or to change the limits of the integral from x to u. So I would go back to x. So I don't want to write here. Yeah, I will go back to x. So I will have half limit t to infinity, and this minus I can take it out, okay? And I have 1 over 2 u to the power 2, and u is 2x plus 1 squared. And now I can replace x by 1 and t. So x from 1 to t. This is negative half times limit of, now if I replace x by t, I will have 1 over. Even this 2 can be taken out to make it 4 and cancel the 2 here. It's okay. So get rid of the numbers. And now 2t plus 1 squared minus 1 over 2 plus 1, 3 squared, 9. So I have negative 1 over 4 times. Now if I replace t by infinity, this would be 2 times infinity, infinity plus 1, infinity square, infinity 1 over infinity 0. So the limit of this is 0, and the limit of this is negative 1 over 9. So the answer would be 1 over 36. So this integral converges. Again, same. I write it, limit when t goes to infinity from 1 to t ln x over x to the power 4 dx. Now let me evaluate this integral here. Okay, so integral of ln x over x to the power 4, I'll take u to be x to the power negative 4. Sorry, this is dv. Of course, I'm using integration by parts. I have x with ln. So actually u is ln x as usual, and du is 1 over x dx. And now dv is x to the power negative 4. And integrating this, I'll have x to the power negative 3 over negative 3. And this is in fact negative 1 over 3x to the power 3. Okay, so this integral would be u times v, so I will have limit t goes to infinity of uv. So it is negative ln x over 3x to the power 3 minus integral v du. So when I multiply v times du, there is a minus sign, so it would be plus, and there is a 1 over 3, okay? And x times x cubed is x to the power 4, so it would be x to the power negative 4 dx. Okay, and all from 1 to t if you like. I'll do it now. I have limit t to the power infinity. Now negative ln x over 3x cubed plus, this is the integral of x to the power negative 4 is this one again, this one, okay? Multiply by 1 over 3. So I will have negative 1 over 9 x to the power 3. All of this should be from 1 to t. So I will have limit t goes to infinity of negative ln t over 3t cubed minus 1 over 9t cubed, okay, minus, replacing 1 by 0, ln 1 is 0. Then here, minus times minus is plus 1 over 9. Now let me replace t by infinity. Ln infinity is infinity. Negative infinity, notice here I have negative infinity over infinity cubed. So negative infinity over infinity. So to find this limit negative ln t over 3t cubed, I have to use L'Hopital's theorem, L'Hopital's rule, because I have negative infinity over infinity. So let us find the derivative. So using L'Hopital, the derivative of negative ln t is negative 1 over t, and the derivative of this is 9t squared. So in fact, I can rewrite this as negative 1 over 9t cubed. And now if I replace t by infinity, negative 1 over infinity is 0. So this limit, the first one, will go to 0. Here, 1 over infinity is also 0. So the answer would be 1 over 9. So it is also convergent. Now here there is no infinity. I notice that the denominator would be 0 if y is 2. So this function is not continuous at 2. So I write it, and please review section 7.8 here, I think. Yeah, improper integral. So I write t instead of 2, and I approach 2 from the right. So this would be the integral. I change it to limits, the improper integral. And now let us think of this integral alone without the indefinite integral y equals square root of y minus 2. I have problem with y minus 2 because I cannot distribute the root, so I will call it u. And then du would be dy. And then this integral y would be u plus 2 over square root of u. And now I can distribute. I can say what u over square root of u, that's u to the power half, plus 2 times u to the power negative half. And the integral would be u to the power half plus 1, 3 over 2 times 2 over 3, plus 2 u to the power negative half plus 1 is half over a half, or multiplied by 2. And now I can replace u by y minus 2. So this would be limit t approaches 2 plus of. Now the integral is 2 over 3, and u is y minus 2 to the power 3 over 2 plus 4, and u is y minus 2, sorry, y minus 2 to the power half, and all of this should be from t to 6. So let me replace by 6. 6 minus 2 is 4. 4 to the power 3 over 2 is 8. It is 8, okay. Just checking, okay. So 2 over 3 times 8 plus 6 minus 2 is 4. 4 to the power half is 2. 2 times 4 is 8 minus. Now replace y by t. And minus again. And now replace t by 2. When I replace t by 2, 2 minus 2 is 0, 2 minus 2 is 0, so this would be zeros. And the answer would be 16 over 3 plus 8. So that's the final answer. And it is again convergent. Here the number that makes the denominator 0 would be 3x equals 2. So x is 2 over 3. And this number is between 0 and 1, so the function is not continuous. So this is an improper integral, and I have to write it from 0 to 2 over 3 plus from 2 over 3 to 1. And now let me evaluate one of them. Okay, so let me evaluate the first integral. So the first integral I write it limit. 2 over 3 is the one I have problem with, so I call it t. And I take t to 2 over 3 from the left. And I have 1 over 2 minus 3x dx. Now, this is the limit. Now, the integral is ln absolute value of 2 minus 3x over negative 3 from 0 to t. So I can take negative 1 over 3 out. And let me replace x by t. And now when I replace x by 0, I have ln 2. Now when I replace t by 2 over 3, 3 times 2 over 3 is 2. And 2 minus 2 is 0. Absolute value, this would be a 0 positive. And ln 0 positive, is negative infinity minus ln 2, so it would be negative infinity, times negative 1 over 3, so it would be infinity. So this integral is divergent, hence integral from 0 to 1, 1 over 2 minus 3x dx is also divergent, because half of it is divergent or part of it, so it has to be divergent. Here I have problem with the 0, so I will write it limit t approaches 0 from the right, t to 1, and let me write this as x over square root of x. This would be x to the power half minus x to the power negative half dx. So this would be equal to limit t approaches 0, integral of x to the power half, x to the power half plus 1, integral to the power x to the power negative half is x to the power half over half, or 2, from t to 1. If I replace x by 1, I have 2 over 3 minus 2. And let us replace x by t. Minus will make it a plus. Now if I replace t by 0, 0 to the power half is 0, 0 to the power 2 over 3 is 0, and the answer would be 2 over 3 minus 2, and the integral is convergent. Here the number that makes the denominator 0, there are two numbers, 0 and 1, because this can be written as x minus 2, 0 and 2, okay, not 0 and 1. So 0 and 2 will make the denominator 0. So this function is not continuous at 0 and 2, but the interval is from negative 1 to 1. So only 0 is in this interval. So I write it from negative 1 to 0. Because I have problem with 0. The function is not continuous at 0. Okay. And now let me evaluate, for example, the second integral. Let me evaluate this integral. So 1 over x squared minus 2x, let me write it 1 over x times x minus 2, and using partial fraction. So A is, if I replace x by 0, forget about this one, negative half. B is, if I replace x by 2, forget about this one, as half. So I, if I call it I, it would be equal to limit. I have problem with the 0, so t approaches 0 from the right, from t to 1, integral negative 1 over 2x, a is negative half, plus 1 over 2x minus 2 dx. So this would be equal to, I can take half out, and the integral of negative 1 over x is negative ln absolute value of x. And then we took the 2 out, so ln absolute value of x negative 2 from t to 1. If I replace x by 1, ln 1 is 0. And here I have 1 minus 2, -1. So the value of -1 is 1, then 1 is again 0. So I replace it by t negative. There is a negative now. With this negative, it would be positive. And this one would be negative. And now if I replace t by 0, this would be negative infinity. And this would be ln 2. So negative infinity minus ln 2 is negative infinity times half. So this will go to negative infinity. So this integral is divergent. And hence the original integral from -1 to 1 is also divergent. That's the end of review exercises about chapter 7. I hope you enjoyed